Okay, Lithium Australia, what are we all about? Processing technology to a large extent, low emissions, low cost, product recycling, and that ultimately gives you sustainability in the battery metal industry, something that is very sadly lacking at the moment. But just to put you in the right picture so you can figure out where all this came from, no surprises that the EV industry to a large extent is driving a lot of what we're doing and a lot of what other producers are doing. And I think it's worthwhile looking back at where we came from. There was the Stone Age, the Bronze Age, the Iron Age, the Industrial Revolution, electrical power, and today we're in the battery age. So how did that come about? There was Volta, that's about 1800. Edison and his DC power, much of that right here in New York. His arch rival and employee from time to time, Nikola Tesla. Edison then invented the electric chair to show you how dangerous AC power was. Got a patent and got it used in a couple of places. John B. Goodenough, the father of the lithium-ion battery. Panasonic, who decided the best application for this was, yes, the camcorder. Forgot about all the other bits and pieces. And then there's Lithium Australia. But last night I had the great pleasure of going down to the corner of America and 40th, kissing the footpath and paying homage to Nikola Tesla. So what am I going to tell you about today? There's the energy metal cycle, disruptive technology that we can get a bit of leverage out of that, and investment opportunities in Lithium Australia. So we're all about closing the loop and making sure a lot of these materials that otherwise wouldn't get processed do get processed, and when they're processed they actually stay in that manufacturing cycle. We've got a number of business units. There's silage, which is primary processing technology, leaching from all silicates. There's VSPC, which is cathode powder manufacturing technology, which is a logical dovetail to VSPC. There's RCARC, which is recycling technology that you use once the batteries have been expended. And to back that up, we've got an exploration portfolio, which is really an insurance policy. That exploration portfolio covers projects in Australia, a lot of them in Australia, Mexico, Europe, where we have a maiden resource, and various corporate partnerships in North America. Here's the energy metal cycle. I've mentioned, oops, how do we go backwards on this thing? I've mentioned the energy metal cycle. The blue sector is primary processing, where we can take material from mine waste, convert it to lithium chemicals, then into VSPC, taking those lithium chemicals, producing cathode powders. At the bottom of that cycle, someone would normally make batteries. You'd use it in your mobile phone, throw it in your bin, and it'd end up in landfill. Only about 10% of these batteries globally get back into the cycle itself. So we've developed a fairly significant research program in Australia and North America, looking at the recycling of those materials and how best to accomplish that and get them back into the recycling or into the energy metal cycle. But what do you need to do this? A fair bit of technology. Our flagship technology is silage. It's a superior processing technology, doesn't require roasting, and capable of extracting lithium from any silicates. Now, a lot of those silicates in the past have been thrown away and still are, and in particular industries such as tin, tungsten, tantalum, and the China clay industry mine these things and throw them away. And why do they throw them away? Inadequate technology for processing them and processing them at a profit. We've got around that problem by developing the silage process, which on front end is sulfuric acid leach to a large extent, enhanced by the addition of calcium fluoride, completely dissolves the silicate minerals. And then you use a standard sequence of base metal processing steps to recover various metals from the soup or reject others that you don't want, ending up with only lithium and potassium in solution. You recover the potassium as potassium sulfate, goes straight into the fertiliser industry. The lithium as lithium carbonate. There are a couple of interesting steps in between that we have developed, and I wish I could tell you about them, but I haven't told the ASX yet, so you'll have to watch this space. But they're all about water balance and the ability to recover lithium out of solutions without evaporating the water. But we've found a way of doing that. How do we progress this? We've got a large-scale pilot plant under design. Location will be the Eastern Goldfields in Western Australia, where we're currently finalising a deal with an existing mineral processor. That'll give us access to power, gas, water, road, rail, and fairly importantly, already permitted tailings disposal. Part and parcel of building the plant in that location is the feed. The feed will come from a number of sources, some third-party sources, and our own lepidolite hill deposit, where we're going to process dumps that you can see there. The vaguely purple stuff is lepidolite or lithium silicate that normally goes to waste. Our processing technology can handle that fairly readily, and the processing plant will be flexible, being able to handle all of those materials, and it will also incorporate a module to use the so-called Elmix Process, brought to you by Lepidico Limited, who are talking in about 20 odd minutes, and they can tell you all about that. We own the rights to that process, exclusive rights in Western Australia. So going further down the track, having produced those lithium chemicals, we can produce then cathode powders. And I have to say that VSPC has managed to produce some of the best quality and best size cathode materials of any available anywhere in the world. And size does matter. This is the size that most companies produce at. Here are the leaders in the industry. And then if you go to VSPC, those little particles in that square are what we can produce. And if you look at these couple of images, the scale bar on the right-hand side is 10 microns. The scale bar on the left-hand side is 100 nanometres, so these particles are nanometre-sized particles. Commercialising that, we've got a small-scale pilot plant up and running. We're currently producing batteries in Brisbane, and we have the most sophisticated battery testing facility in the Southern Hemisphere. There you can see parts of there, and on the right-hand side, large-scale pilot plant to be recommissioned in the next couple of months. So we are the only company capable of taking mine waste, the minerals that people discard, throw away, can't use them because they've got no economic means of processing it. We can take those minerals, we can economically process them, we can go straight through to cathode powders that go into the batteries. And the economics in doing so are quite staggering, really, in that if today I produce a tonne of lithium carbonate, I can get something like $10,000. If you believe the newspapers, 15 or 20, but let's call it $10,000. I can add a few fairly mundane chemicals to that, increase the mass fivefold, and for every tonne, which is now 5 tonnes, I can get something like $35,000 a tonne. That's the place that you want to be in the battery cycle. That's the absolute maximum uplift. And then, of course, once those are disposed of, we can pick them up. The little packets effectively are embedded energy and materials that people have spent a lot of time, a lot of money refining. Why put them into landfill? We've got to keep them out of landfill. So that gives you a completely integrated process flow sheet that'll handle all of those aspects of the battery metal cycle. 100% owned with respect to VSPC and silage, and RC, ARC progressing very well. So what have we got? We've got the ability to transform waste materials into cathode powders. We're committed to a large-scale pilot plant for the silage process. We've commenced the recommissioning and in fact are producing batteries as we speak today in Brisbane. And we've commenced the recycling on a laboratory scale of lithium-ion batteries. We've got a significant resource in Germany that underpins all of that, and we have investment opportunities at every level of the industry. There's the three wise men. A few corporate details. We've got about $20 million in the bank. The most important thing's our address. We're right in Lithium Valley, and Lithium Valley is a project initiated by the federal government of Western Australia who wants to foster this sort of technology. Thank you.